Okay, so I want to figure out if this series converges absolutely, if it converges conditionally, or it diverges. And the first thing that I take note of is that it is not possible for this series to converge conditionally because all of the terms are positive. So I can eliminate conditionally convergent since all of my terms are positive. Now I'm actually going to use the ratio test because this involves factorials. And remember, the ratio test is really powerful when your terms involve factorials. And I've written here the ratio test here on the left, right? So the first thing I need to do is I need to find L. And remember, L is the limit of the absolute value of the ratio of consecutive terms. So let's just get started. What is a sub n? So a sub n is going to be n to the n divided by n factorial. Once I know a sub n, I need to figure out a sub n plus 1. All I do is replace replace n with n plus 1 everywhere I see an n. So how this can be tricky is if you don't replace every n that you see with an n plus 1. Okay, so I've got a sub n and I've got a sub n plus 1. Now I need to look at my ratio a sub n plus 1 over a sub n. So that is going to be n plus 1 to the power of n plus 1 over n plus 1 factorial. And let me make this a little darker here. And I want to say divided by n to the n over n factorial. Okay, so obviously I need to do a lot of rearranging. My algebra skills are going to come into play here. So let's rewrite this. So we'll have a sub n plus 1 over a sub n is equal to, I have n plus 1 to the power of n plus 1 over n plus 1 factorial. And then I'll have n to the n, and then up here I'll have n factorial. So I'm going to, let's make sure you can see what I'm doing here. So as I rewrite this, I'm noticing that some things can cancel out. So, for instance, I'm going to kind of group together the n plus 1 to the n plus 1 over n to the n. So I'll have n plus 1 to the power of n plus 1 over n to the n. And then I'll also have left over here n factorial over n plus 1 factorial. So I have n factorial divided by n plus 1 factorial. Okay. And so now this is equal to, now the n plus 1 to the n plus 1, I can write that as n plus 1 to the n times n plus 1. Okay, and then over n to the n. And the n factorial over n plus 1 factorial. N plus 1 factorial is the same as n factorial times n plus 1. So n plus 1 factorial is the same as n factorial times n plus 1. Excuse me. That's going to help us because now the n factorials cancel out. And my ratio is now going to be equal to, and I can combine this n plus 1 to the n over n to the n. I can write this as n plus 1 over n to the power of n times, now look, my n plus 1 and n plus 1 cancel out. So that's all I have. Okay, so what have we done so far? We figured out that a sub n plus 1 over a sub n is equal to n plus 1 over n to the power of n. So let's write that down here. So a sub n plus 1 over a sub n is equal to n plus 1 over n to the nth power. Now I need L, which is the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. So I need the
It's
limit,
11:30.
thank you, as n goes to infinity, of the absolute value of n plus 1 over n, all to the power of n. This is going to be the same as just n plus 1 over n to the n. And this is actually equal to 1 plus 1 over n to the n, because I can, on the inside here, I can rewrite the inside as n plus 1 over n is equal to n over n plus 1 over n, right? So I get 1 plus 1 over n, limit n goes to infinity, and this is actually equal to e. Okay, so we actually have a video that explains, way back when we did our review of limits. This is an indeterminate form because it's of the form as n goes to infinity, 1 over n is going to go to 0, and the n is going to go to plus infinity. So this will have the form 1 to infinity, which is an indeterminate form. And so you can use L'Hopital's rule to figure out that this limit is equal to 0. And I'm not going to review that here, but make sure that you know how to compute that limit and reach out to me if you can't remember or you need help figuring out where it's posted on the video, how to work with those limits. So the bottom line for us today is that L is equal to E. So what is the conclusion? Well, we've got to know, is E bigger than 1? Is E less than 1? Because this is what we use. E is bigger than 1. So since L is bigger than 1, our series, n to the n over n factorial, diverges. And in fact, this is in line with what we would expect, because if we look at the nth term divergence test, the limit as n goes to infinity, n to the n over n factorial is not going to be equal to 0. Why not? Because n to the n over n factorial, that means n times n times n. You've got n n's, and in the bottom you've got 1 times 2 times 3, all the way up to n, right? So n to the n over n factorial is going to be we could actually probably solve an equality to say that this is always bigger than or equal to n for n large. Okay, so but figuring out how to prove that this doesn't go to 0 is more complicated than just applying the ratio test. Okay.